Now, without further ado, I would like to welcome to the stage Ken Savin, CSO of RedWire, Ken Shields, Director of Commercial Market Development of Sierra Space, Mike Johanson, Senior Vice President of Business Development for Zen Technologies, Siobhan Malany, President and CEO of Micro-gRx, Sean Tully, Director of Systems Engineering for Commercial and Civil Space at Northrop Grumman Corporation, and the lovely moderator, Cynthia Bouthot, President of Space Commerce Matters. Let's welcome them all, please.
All I know is, are you guys crazy? Why did everyone not stay outside and then force us to go do the panel outside? It is beautiful weather out there. But thank you for coming back in. Hopefully we can have a really interactive discussion. I know it's been a really long and packed day, and we've been having, or at least I've been having, lots of information coming in. So what we really want to do is make this panel for the next hour be really a conversation with all of us. What I wanted to start off with is, this morning we talked about this continuum of the Earth, Moon, and Mars. The one thing I didn't mention is, as every government, as every space agency focuses on the exploration agenda, that's where they want their budget dollars to go. And hence, they're really promoting this commercialization of LEO. And it's not just in the US, it's literally across the planet. That's really underpinning a lot of what we're going to be talking about today. As I said, there's been a tremendous focus on the supply side, but what about that demand side? How are we going to accommodate all of this activity and this total addressable market that I was talking about before? And we're not going to do it based on just the International Space Station, which to date has been really the only asset in space. What we have seen is that in 2021, 2020, we've had record levels of investment, and that we're going to be talking today about some of these things. So the folks here on this panel really represent the majority of the investment we're seeing here. We're going to talk about Orbital Reef. We're going to be talking about what NASA's doing with its new space stations, what RedWire is doing with the acquisition of lots of manufacturing companies. This is ultimately a real turning point, an inflection point in our ability to truly commercialize, because without these facilities, you really can't accommodate all of the activity. What we've been talking about, at least from a Space Commerce Matters perspective, and I'm sure everybody here on this panel talking about the same thing. Before this, you would have an International Space Station where you would have, maybe if you're Nicole Wagner, you go up 3 times in a year from Lam Division, and we'll be hearing about from her tomorrow. But that's rare. It's very difficult to have up mass, down mass, and have that actual execution of your projects in a continual fashion. So what we're trying to do with the commercialization of space is really match a terrestrial product development cycle with space-based assets. So one of those flights could be the space station. One of them could be to the Orbital Reef. One of them could be using Sierra Nevada as a new transportation system. One of them could be using new satellites and using new focus areas. One could be on the Northrop new space station. So again, we're talking about really an explosion, and I know we should not use that word in our industry, but really an explosion of many different types of options. And just like terrestrially, as if you're a pharmaceutical company, you might go you might go across the road to one contract manufacturer, and to do something a little bit more precise, you might go from Pittsburgh to California. This is the same type of thing, where you might use one asset for one thing and a different asset for a different type of activity. So this is really exciting times. In terms of these commercialization opportunities, again, hopefully you guys are teeing up questions around this. The 3 new awards around Orbital Reef, Starlab, and the Northrop Grumman station, and maybe we'll find out what the secret name of that Northrop Grumman station is today from Sean. Artemis, everything that's going on right now with all of those amazing things. And Bill Nelson, the NASA administrator, was so inspiring today as he talked about that. And again, Mike, what is Zen doing related to Artemis? The CLIPS contracts, the ability to actually engage commercially with all of these government programs supporting the moon, and then communication systems and optical and laser comm, and how do you get big data up and down. ESA has been focused on commercialization. I'm personally working on a business and space growth network with the European Space Agency on sustainable agriculture and food. And they're looking at opening up a whole variety of options and funding sources to really get that whole sector going and, again, go off our planet to save our planet. And what you're seeing with these commercialization efforts is the underpinning of our ability to use the assets that we're talking about here. So that was my last slide. I didn't want to bore you, and I'd much rather hear from these guys up here on this panel. But the panel here today is representing new space stations, new transportation systems, new terrestrially friendly facilities. How do you use something up there just like you would use it on the ground and use those same business models? Although competitive, this panel is actually actively collaborating with many different partners, and I'm dying to hear about those collaborations because it really does take the village for us to build this commercial marketplace. And again, this notion of what we're doing in space and replicating terrestrial models, so I would love to hear more from the panel on that. There are still challenges to face, and we are going to be hopefully getting into some of the themes that you guys all came up with today in terms of what more is there to do and how can we remove some of these challenges. I'd love to hear from these facility and capability providers on how to do that. So let's hear from them now. So Sean, why don't you give us a little overview of what you're doing with Northrop?
This is what I get for sitting closest to the moderator. Hi folks. Thanks again for having me here. I've had the pleasure of working at Northrop for over a decade now. I've been able to work on the CRS program, or Cygnus spacecraft, which has just flown its NG-17 mission, and if I can just plug, at the end of the month, we are supposed to be demonstrating our real reboost capabilities for the ISS, which is very exciting for our team. And then we're also working on the Halo module as well, which is a program I was also intimately involved with, which is the habitation module that's going to be built for the Gateway Station as well for the lunar outpost. As you mentioned, we do have an award with the Low Earth Commercial Destination, and that's something that we are trying to leverage a lot of the work that we've been doing with CRS and Cygnus and Halo to provide a solid habitat for low Earth orbit and for science and for commercial space and other industries as well, and to help keep a lot of the progress going. In fact, I would say if you looked at the past 20 years for the ISS, for how much it's achieved, it only makes sense to keep that going. So we have a pretty excited team that we've built up pretty much over the past 15 years that's been getting more involved with human space, and just really excited to keep building upon that.
Great, thank you. Siobhan, why don't you tell us about Micro-gRx and, again, how you're working to really create platform technology that allows a terrestrial user not to have to relearn a whole new way of doing something.
Right. So Siobhan Malany, I'm president of Micro-gRx. I founded that through seed funding from Space Florida, through the Florida Israel Innovation Program and Cases Organ on a Chip Challenge. We're now part of the Tissue Chips in Space initiative, which is funded by the National Institutes of Health. So Micro-gRx has been uncovering the effects of microgravity on tissue, on cells, and using that as a tool platform for medical research, for fundamental biology studies, and for biotechnology application. I'm a drug discovery pharmacologist. I have a long career in the biotech industry in high-throughput screening, lab automation, and then moving small molecules toward IND-enabling studies. So with Micro-gRx, the concept is to translate these terrestrial tissue models to this unique environment of microgravity where you might have an accelerated disease process that can mimic aging. So we've been focused on the autonomous laboratory and a muscle lab on a chip system. This is in collaboration with Space Tango. In 2020, we showed, I think for the first time, the contractile function of these muscle bundles from space, looking at mechanobiology pathways. And later this year, we'll be delivering a natural product that's an anti-atrophy compound that's shown some good activity in mouse models for anti-atrophy. In this, we'll test this on our muscle tissue chip platform as a way to get human efficacy response. And so that's the idea, to design these for relevant disease models, to look at that for efficacy testing, and hopefully replace animal models. We're also really starting to collaborate with RedWire to bioprint muscle on the space station. I'm really excited about this concept, to now not only use that as the same kind of platforms, but to build more volumetric tissue that would be scaffold-free, could have more structural integrity than what could be bioprinted on ground, and then this will serve the organ transplant field for volumetric muscle loss, for traumatic injury, for combat injury. So this is really an exciting area. So these are some of the platforms, these medical platforms that could really drive applied research and development in space. And so really excited about continuing this conversation and how Micro-gRx can be an enabler in this sector.
Great. And Mike Johanson from Zen Technologies, a great company in Cleveland that's been around for a long time, but also doing really cool new things, especially related to the moon and other moon, Mars, and beyond.
Yeah, I'm Mike Johanson. I'm Senior Vice President at Zen Technologies. I've been with the company about 15 years, but it started back in 1957. We've had our very first NASA Glenn contract in 1969, and we really grew up at the NASA Glenn Research Center. We are now at 5 different centers, so we've really moved out. But we started off being kind of this microgravity science and technology development company, working first in shuttle missions, then Mir missions, and then space station. We have over 400 payloads that we've flown to date on those platforms. We had in space station, we had one of the very first science payloads operated, PCS. We've had the longest running payload, which is the Space Acceleration Measurement System. We have 3 laboratories on space station, one that just came down, but the Fluids and Combustion Facility, both racks, including the light microscopy module, which is an automated microscope, when a workhorse on space station is our hardware. We've been operating those facilities for more than a decade, and we're very proud of our accomplishments in ISS, but we've really been moving out and spending a lot of time diversifying and going into these new areas. So we are working in the Artemis Program. We've done lots of work, everything from the vibroacoustic test facility to test the hardware at NASA Armstrong in Sandusky, Ohio, to development of being on the team that's developing the universal stage adapter for the SLS for a Block 2 configuration. We're also teamed with Northrop Grumman on the Halo and hopefully on similar systems on their commercial LEO destination as well. We like to catch their Cygnus on fire. If you ever see a combustion payload on space station or in the Cygnus, right before re-entry, we create large fires studying spaceflight safety for the Moon to Mars missions for the Artemis astronauts. We're also teamed with Sierra Space. We just delivered and power the power systems for their Dream Chaser. And we're now moving into the commercial LEO destination world as a partner at the George Washington Carver Science Park, developing with NanoRacks and Voyager the future for their commercial space station, with a key to being flexible and agile for the future of science.
Thanks. And Ken Shields, who is the Senior Director of Business Development for Sierra Space and a longtime colleague at the ISS National Lab. Ken?
Thank you, Cindy. Good afternoon, everyone. Ken Shields, Sierra Space. Great to be here. How nice is it to be in person at a conference like this? It feels like it's a big reunion, seeing folks that you haven't seen in a while. So thanks again for the opportunity. So Sierra Space, a little bit about our company. we're a new commercial space company, but a little bit different than most new commercial startups in that we were carved out from a company called Sierra Nevada Corporation, which has been around for over 3 decades. So we have a great tradition and legacy of flying all kinds of payloads in space, a lot of different subsystems and applications, including solar technologies, ecosystems, rocket engines. It just goes on and on, shutters, valves, hatches. But now we carved out this new company, Sierra Space, in June of last year, June of 2021. We did that because we recognized that we needed to be a lot more nimble, much more outward facing. We needed to move more towards frankly, a sales model and try to compete in the commercial sector in a way that we couldn't when we were Sierra Nevada Corporation. So really our mission and vision, we're right now in the midst of developing really some amazing in-space platforms that are going to enable all sorts of improvements to life here on Earth. We're a technology differentiated company, and we want to leverage those technologies to democratize access to space, to accelerate innovation, and to enable companies just like the ones we're talking to here at the Keystone Space Collaborative. We want to bring you to space. We want you to use our technologies like the Dream Chaser space plane, which will fly its first mission in early 2023, first of 7 missions under the CRS-2 contract with NASA. What's awesome about the space plane, it comes back to Earth like a glider. About a 1.5 G load coming down, lands on a runway that can accommodate roughly a 737. Very nice soft landing. Best part of all, you reach in there maybe within an hour after landing, get your cargo, get your payload, get your research, take it to your lab, you're up and running. 2026, we're going to have the DC-200 space plane, which is going to be carrying people. Once again, soft landing, not going to float around out there in the ocean and get seasick. We're going to put you right on a runway. You're going to climb out within 30 minutes, get in your limousine, get in your bus back to your barracks, and off you go. Another technology we're excited about is our Life Habitat. That's a large, integrated, flexible environment. We love acronyms. The Life Habitat is a very large volume, large capacity, soft-sided habitat that initially we're going to deploy in LEO, but it's also a surface habitat, deep space exploration, has all sorts of applications. To give you a sense of what we can do with a soft-sided platform like that, or soft-sided technology, we can get about 300 cubic meters of pressurized volume to LEO in one launch. That's about 1/3 of the current pressurized capacity International Space Station, which took, how many launches, Mike? A lot, dozens, 40, 42, I don't know, 62. A lot. So lastly, it's also going to be a significant, a major element. Both our Dream Chaser, transportation, Life Habitat, habitation modules going to be very, very important elements to a partnership we have, an enterprise partnership we have with Blue Origin called the Orbital Reef Space Station. It's a commercial space station. We're right now working under a Phase 1 CDFF with NASA. Once again, we're putting that up there to enable the research and the business and facilitate all of you folks out there to operate in space. So thank you.
Great. And last but not least, Ken Savin, Chief Scientist at RedWire.
Hi, everyone. Hello. My name is Ken Savin. I'm a chemist by training. Sort of stumbled my way into aerospace. Actually, I worked at a pharmaceutical company in Indianapolis for 20 years. And towards the end of my career as a chemist working in a pharmaceutical company, I got a call from Cindy. And she asked, hey, would you like to do science in space? And I did, and got a bunch of my buddies to do the same. And we ended up flying 5 different experiments on station over a span of 4 or 5 years. And retired from Lilly, went to work for KSC with Ken and with Cindy, and helped other companies do the same. And if you look at my approach to the aerospace industry, I look at it from the standpoint of, hey, there's people who enable work to be done in space. They build habitats, rockets, hardware, and the company I work for now, RedWire, does that as well. We just put the new solar panels on the space station. We built those. We build high-performance cameras for navigation in space. And at the same time, we build hardware that allows people, just as Zen does, to enable your science to be done on station in the microgravity environment. And I look at that a little bit different. So there's enablers, but there's also the people who are saying, hey, what can I make in space and use as a benefit back on Earth? You could potentially make things in space and sell them to people in space, but it turns out that's a small market right now, right? There's not, 11 people in space. That's your population. Where if you could make something that needs to be made in the microgravity environment and bring it down, that could potentially be a really big market. That could be the market. So that's where I spend most of my time at RedWire, helping other people get their science done and looking for opportunities to expand our horizons into space through the work we do, but also to draw in interest and ultimately capital, the investment to people who think that it can be done.
Great, and I'm just going to ask a couple questions and then quickly be thinking of your questions because we want this to be very interactive. But you each gave a perspective along that whole continuum. If I'm just in your old job, if I was Eli Lilly and I wanted to do some outsourced contract research, as pharmaceuticals typically do, what would you describe that end-to-end journey looking like today versus back then? Like, are we almost there? Are we almost able to give that end user that seamless experience between, what they would actually face if they were dealing with a terrestrial CRO? No.
But it's not all our fault, right? You go to the average American and tell them, hey, would you want to do stuff in space? That's going to be the same reaction I had. Is like, you got to be kidding me. I thought you were actually just somebody in the cube farm having fun with me, right? Somebody from calling me up to do work in space. So I think there's a psychological disconnect that people have. At the same time, there just aren't the processes. Things take a lot longer. I mean, there's a lot of reasons why. But once you get into the rhythm and you see it and you see an opportunity, it makes it a lot easier. I have to give a lot of credit to the guys at Zen. They were when I was an investigator, they were one of our implementation partners, and they actually, we went out to Glenn, met with the people at NASA, went to the Zen facility, took a look at how the hardware would be built, and talked to them about the engineering side, which was part of what my company wanted, what Lilly wanted. We wanted to see how other people think. And then Zen went the extra step and said, hey, once we start to build this, you're coming back and you're going to be part of that process. And we went back to Zen and looked at the hardware and saw the flaws and kind of fixed them together. And I think that's part of what needs to be done. It's doing work in space is very different than me going into a lab or even me going into a production facility, like I was at Lilly to get things done.
But Siobhan, aren't we changing that with the way that we're thinking about how how you're building your solutions for volumetric muscle loss or what you would be focused on from a toxicity testing or whatever? Are you, talk about what that journey looks like for you.
Yeah, I agree. It needs to be more seamless, and I think that it's changing the landscape. But, before it was sort of, it's quite a hurdle to implement your science for space. I mean, before it's sort of like, here's your implementation partner list, go out and figure out who you could partner with, what they do, and as an investigator, it's just this huge barrier. I mean, I think with the Tissue Chips in Space program, up front, the thought was that it would be a 50% failure rate. So we have to change that because it's very expensive, it's very time-consuming, and needs to be seamless. I mean, if it sounds difficult to put a whole lab inside a shoebox and remote control it from space, it's harder, much harder. So I think, now we're thinking in terms of sending raw materials up. I like the biofabrication is great in terms of just cryopreserved cells, putting it up there, doing your bioprinting in whatever format, and then moving that along. Just like in the high throughput screening platform, I see a lot of parallelisms. We package that, we miniaturize it, it's enclosed, it's automated. So doing those kinds of things from end to end, so you're doing your imaging and your omics or whatever your readouts are, in that environment, you can really, miniaturize what we already do perfectly on the ground. There's a lot of high throughput automated systems that could be toned down or even do acoustic dispensing. It's not based on gravity that you could put and do these kinds of things in a platform based.
I think it has evolved, and I'll give you an example. This week we're actually flying a commercial payload for the Ramon Foundation in Israel. It's a medical experiment that they came up with and they built, and within 6 months we were able to go with them. They don't want to be the experts on how to fly it in space, they just want the data. They handed over the hardware, we hardened it, we got it ready for flight, we actually integrated it, tested it, and operated here just this week. And it was very successful, but it is real important that you do pick somebody who has knowledge in how to do those things rather than becoming the expert. As an example, they had built all their software originally on a computer in Israel, and it was a 50 hertz computer, whereas they were interfacing with a 60 hertz computer on space station. So little things like that you have to know the nuances of that you might not expect. But times have shortened. The amount of time for paperwork and those things have definitely changed over the years, and we're able to be a true implementation partner.
And Ken Shields, after coining the term flybilizing, which is taking your payload and like having the experts make it flight ready, what is your perspective on what we're talking about now, this end-to-end service? How do service providers ensure the reliability that things are going to work for their customers, especially with your new hat?
Yeah, I would agree with Mike to a degree that we have seen some improvement, but flybilization has not occurred at the rate of velocity that I would like to see it, Cindy, that's for sure. But part of that also is just the fact that we're still tied to the systems that we have in microgravity, and right now I'm referring mostly to the ISS because that's where predominantly this kind of R&D occurs. And unfortunately, you can only do so much. You can only move so much, make so much progress and innovation when you're still working with a system that is not new. I'll say it like that. I mean, it's a system where when you're in it and you're working, one of the descriptions I've heard, it's like you're inside a VCR. And that doesn't sound like a laboratory environment in almost 2030. And so we have an opportunity now, right now before us as we're working on these emerging commercial stations to do it wholly different. So what's great about that is we've learned a lot from the ISS, right? We've learned a lot from an engineering and technology side. We've learned a lot about logistics and operating in space. I would almost say that in that area we have advanced pretty quickly how to access space and operate in space and do it safely and even with a fairly high level of reliability and assurance. And now I think we're just sort of entering the dawn where, and everyone talks about it, it's now the era of results, it's the era of utilization. And so now I think we have the ability to start working on those finer points for folks like Siobhan and folks like Lam Division, Nicole Wagner, and Dr. Ed Linska, who was working on cement in space from Penn State University, I think, and so many others. And so when we move these next platforms, we'll bring the good lessons with us. We'll certainly clean up a lot that we can clean up from ISS, and I think we can really shorten the design cycle and the development cycle and do a lot more in-orbit analysis and iterative science. My goal is to, as an example, we need to try and think about how can we sort of break the paradigm of activity and utilization in LEO and other places being directly tied to a launch schedule, right? It's like we launch and we're busy and we're innovating and we're discovering and then the thing comes down and we're dead for 3 months. We've got to stop those crazy cycles of up and down,
exactly.
and that's going to be a big focus of ours for sure.
All right. Sean, do you want to comment on this before I ask you guys have been too friendly, so I'm going to ask a question that might make you not friendly, but why don't you comment on this?
No, I'll add to what Ken and Mike has said. I'll say, speaking as a service provider, just in general, we've seen a shift in engineering, design, and development to be less focused on the mission and more focused on the end user and the customer. So in general, the engineers that are actually working on the services to provide, they're no longer working just off of a spec sheet or necessarily maybe what's in a contract. They're looking at what is the end user, what is the overall evolution for this platform. And also there's a lot of technologies that have enabled recently, I mean over the past 15 years, where we've gotten more comfortable with certain embedded processors in space or certain reprogrammable FPGAs where we've had the ability to make modifications and actually design those in. So, for folks out there developing payloads or components, I would encourage you to look at, okay, well, assuming that I can't get this back down on the ground and I can't service it, how am I going to use this in space with perhaps limited visibility, and how am I going to make that work? And I think a lot of that, the industry in general has moved to that paradigm, which is nice.
Great, good. So what we're hearing right now are kind of, in my mind, 3 levels. We've got new facilities and new capability coming online, like the equivalent of a piece of lab equipment or manufacturing equipment, where we're trying to make it more seamless and end-to-end. We have new transportation vehicles that are going up with a certain cadence, 30, 60, 90 days, whatever the case may be, coming back down with the soft landing. The return from the ISS, we did an analysis, is only about 30% of the total up mass, which is a huge bottleneck of bringing things down. And it's a big problem if you ever want to manufacture something. So these transportation vehicles coming down and having a cadence of return really opens up manufacturing. And then we've got new space stations and new habitats where you might go as a tourist or as a, what's the word that I'm looking for right now? As a hotel. So you might go as a hotel guest, you might want to do some science. So what is the difference in your mind? How do you see the split of utilization between hotels in space, science in space, manufacturing in space, supporting sort of commerce, R&D, and manufacturing, supporting tourism through all of these things. And one of the questions, this is not my question, it's somebody on this panel, will we have enough billionaires to support this tourism activity going into the future? Is that a scalable model? So I will stop there and throw that out to you and see if you stay as friendly as you were.
Well, I'll take the bait. No, I'll just point out that, while yes, that's true for return capabilities, the station does require a lot of consumables just to maintain human life on the station as well. And depending on how you want to count return, I'm not sure if we want to count some of the soiled clothes and dirty laundry as necessarily return. But that being said, I think the key is to be flexible. I think you have to understand that it is a limited volume that you have to make the absolute most out of. So if you're designing a payload, it has to be as efficient as possible. You want to not try to use as much data bandwidth to get your data down. You want to try to not use as much touch labor. I mean, just the labor alone for an astronaut is it's invaluable. And it's not based off of the pay grade there. It's based off of just the time available. I mean, every minute is precious in that environment. You want to make the most out of that environment. So I think the key is to just maintain that flexibility.
I think it's going to be market driven. Really the future for commercial space stations is it's not like the ISS. It's going to be profit driven. It's going to be about making money, and so and it's not like you're going to have the subsidies that you would see in space station where you're getting a free launch. You're getting M&I, mission integration and operations, paid for in a lot of cases. Everything's going to be a service, and that includes even communications. It'll be data by the so much data for a dollar, right. And as we start moving away from TDRS into more commercial comm type environments, so you're paying for everything as a service. And so I think it's going to be market driven. You're going to see a little less, I think, of the fundamental science that will still be done by our anchor customers like NASA and our other government customers. But you're going to see a lot of things driven now by how much you're going to make, whether it be shooting a movie or be it vacation of somebody. But you're only going to do so much of that as well. So I think there is going to be a turn to more of a manufactured environment where you do have a product that you're selling at the end of this, and I think that's what's going to drive where we go with the future of the payloads.
I think you're both partly right. Does that make sense?
Are we still being too nice?
Yeah, you're both right, I think. It's not or, it's and. I think that, yes, there will be some level of spaceflight experiences, people wanting to go to space for different reasons that aren't traditional. But I also think it's still very, very important that we maintain, a research capability, leadership in research and R&D and technology in LEO and in space more broadly. And so, yeah, in that they're commercial, certainly turning a profit and generating revenue is going to be extremely important. But I also tend to think that we're still going to be very mindful of the appropriateness of the things that we are doing in space, and ensuring, at least for us, our technologies, we're going to leverage those technologies to do things in space that enhance and benefit life on Earth. And you can think, of the billions of people that live on Earth, they would define enhancing and benefiting life on Earth differently. And so I think that's what we have to provide. The Orbital Reef space station that we're working on, really our view of it is a multi-use business park in space. And so that means you will have all sorts of very interesting activities going on, all sharing this infrastructure. And an important part of this, both of you guys alluded to it, is the scarcity of capacity and constraints of capacity and the cost of doing business in that environment. And as an industry, as a community, that's a side of the equation maybe we don't talk enough about. We've got to drive down our price points. If this marketplace is going to work, we've got to get it such that we can price ourselves to what the market can actually bear to do these things. So yes, it's about driving demand. It's about creating better awareness and understanding and innovating towards new non-traditional use cases and new applications in space and microgravity. But the other side of that equation is let's do everything that we can to be more efficient and more effective with what our investment and what our dollars are over time, so that we can make those ends meet.
Sounds like the new timeshare experience, right? It's like you get to be a tourist and you get to learn how to run a science experiment. It sounds great. It's a new Bonvoy experience. I don't know.
The thing, I mean, we think now, and we're sitting here, and we're in the business, and to sit here and think about how things might be in 2030 or 2040 or 2050, and our vision is hundreds and hundreds of people living and working in space on a normalized basis, right? And I think to the casual observer, they're like, Ken, you're nuts, right? And Ken is nuts, but that's not a crazy statement, because, I mean, we walk around with this thing in our pocket every day that in, 2007, we would have never envisioned that we had the computing power that we do in our jacket pocket, every one of us, right? And that happened in an instance. And we wouldn't have thought, in 20 years ago that we would be sitting here, somebody help me, 22 years of constant human habitation in space. We haven't been a day without a human living in space for 20-some-odd years. Would anybody in 1995 have thought that was going to be the case? I don't know. So earlier, I think it was Senator Cartwright said big ideas, right? Big ideas. Big ideas is what drives our leadership. It's what drives our economy. It's what drives innovation. So we shouldn't shy away from big ideas and pursuing those.
Will there be enough billionaires? And is that who we want running our science or our whatever we're doing up there? And the reality is that for most of the science that's done, it's not done by scientists. It's done by astronauts, some of whom are scientists. And I think you're seeing the trend in technology is the technology is being stronger and more enabling. So you don't have to be a PhD chemist to do the chemistry. It will actually, with some basic training, you can run it. It will even give you feedback that you can understand and do something with. And I remember hearing a conversation with some people from SpaceX about how Elon Musk is looking at the people that he is going to send to Mars. And somebody said, well, how are they going to be prepared? What's their training? What are they going to wear? And he's like, what's all this about? I said, we're sending farmers. We're just going to send farmers because they can figure things out. They're going to be able to feed themselves, and if something breaks, they can fix it. So I think in a way, that's how I'm looking at science, and going to the point of the cycles that we're trying to get out of, where we're launching things and bringing it, and we're so reliant upon that, especially in the beginning, before you're even producing something, just the iterative learning cycle, it's killing us. And what we have to do is build capability on stations so you fly it once and you run all your iterations again and again. You're doing all your testing. If you need to, only thing you're down massing is data, which right now is pretty cheap, relatively speaking, and that's how we're going to make it work. And the reality is, I look at it, the way we do science right now is akin to the way we did science almost like 120 years ago. We didn't have analytical capabilities. An entire thesis would be on a single step in a process that the person would spend 4 or 5 years doing that. And in part, that's because we just don't have the analytical capabilities to do those knowledge cycles in space right now.
But Siobhan is developing those, so we're going to be all set.
That's right.
Yeah, you need technicians that are just run. You don't need, PhD scientists. It's technicians to just make sure, again, it's like the sort of screening thing that things are operating and moving through and shooting out your data. It's really technical.
Yeah.
I appreciate that because I started my career as a technician, so there's hope that I can be an astronaut going to Mars one day.
Your new job as a science technician.
I can follow orders.
So I'm wondering, does anybody out there have some initial questions? I can keep going, but let's make this interactive. It's the end of the day. It's been information packed. I mean, these are the guys that are building guys and gals building the future of commercial space. So, Jonathan?
Is it on? Okay. So what's the deal with all these space stations? There's a ton of them being built. No, on a high level, as I see this from the demand side, I'm thinking, okay, there's going to be all these opportunities. I want to fly something. I have a lot of choices, which is very positive. On the supply side, what's the positive, whoever wants to answer, of having this, call it competition, all these options? What's the benefit for the supply side in the scenario?
Competition breeds ingenuity is number one, but I think especially when I look at CDFF and all the various teams that are working on it, I think you're going to get a diverse range of solutions. And
Can you say what CDFF stands for?
Oh, I'm sorry. Yeah, Commercial Destination Free Flyer. So those are the ones which Cindy here was briefing on earlier. So I think you're going to get a diverse set of solutions. I think you're going to get a lot of industry intrigue and a lot of opportunities to potentially start working on some preliminary designs and start figuring out what looks like a good opportunity for either a component developer, a payload developer, or a service provider. So I mean, you have to definitely look at that holistically for the whole mission and the whole program dynamic and how that's going to work. For global supply, I mean, I would expect in 20 years there are going to be multiple stations. I mean, we already know that China is working on their station and Russia is likely going to work on theirs. So, I think it's just the natural evolution where you're going to see more people utilize the environment and make those business models work to support them, and that's just the future.
I think with that, it gives more access to do return flights. If you're doing these phase-based sort of manufacturing where you need to do phase 1 proof of concept, you need to get back there in a timely manner. So that's going to provide that opportunity as well.
Well, I think it also is going to help with what you heard Astrobotics talk about today. They had to go out to California to test because they didn't have a facility local that they could get into to hit their schedule. I do believe each one of the space stations are going to have a unique, from what I've seen, each one's going to have a unique capability. They're going to have different anchor tenants and different requirements. They're going to feed different groups of people. So while there will be something common amongst them, I think there's a lot of uniqueness in each one of their designs.
All right. Looks like we have another question. Where? Here? Yeah.
Oh.
Okay. Just to piggyback off of what was mentioned earlier, is it just looking at the 30% up mass that actually comes back down to Earth? So are we looking at, I'm not a scientist, don't know space very much at all, so I'm just, for my edification, is it a capacity situation that we're really dealing with, and is that what commercially is being developed right now? Is that to try to expand capacity to be able to address some of these various industry areas, not just tourism, but also R&D, manufacturing? Is that really what we're really thinking about right now?
And
that's
why don't you talk about the vehicle, or both of you guys talk about the vehicles that bring down?
Yeah, you're spot on. Capacity is a big part of it right now. right now, let's focus on the International Space Station once again as kind of the model that we're looking at. Although it's a wonderful tool of innovation, it's also one terrible bottleneck of innovation, right? Because there's a very, very limited number of buses that are going. There's a smaller number of buses that are coming back, and it's just very hard to maintain any throughput. So yes, capacity from a standpoint of just sheer volume and turnover rate and deal flow or project flow is a real challenge there right now. Also capacity from a standpoint of what the capability is within that capacity. You know, right now, as I said before, we're dealing with an aging system, some aging infrastructure. You know, Zen's got some new stuff, RedWire's got some new stuff, but it's plugging into old stuff, and it's operating in fairly old systems. And that also impacts your capacity. So yeah, you're absolutely right. And to echo what my fellow panelists said, I'm envisioning, I mean, if we're going to have a marketplace, we need multiple space stations from multiple companies out there competing, maybe differentiating themselves a little bit from the others, but we need multiple platforms if the LEO marketplace is really going to be functional.
Just to follow up on that then, has the platform of ISS kind of helped not only, I mean, I understand it's opened up this marketplace, but has it de-risked for the idea? Has it de-risked this for commercial organizations to start this new process because of the need to not only build more capacity, but to build advanced capacity that fits really what you need in order to be able to sustain and to grow the marketplace?
Absolutely, absolutely. The ISS has really sort of shown the light for us in a lot of ways. Safety, operating in space, accessing the environment, but also the areas of business and R&D that we should delve into. We actually have a great starting point. And NASA has done a fantastic job. NASA's to be commended for their commercialization programs and strategies that have enabled things like commercial crew and commercial resupply, and everybody you see up here with their businesses as a result of NASA commercializing these opportunities.
And I'll add to that, you know, for commercial cargo, you know, we've got two vehicles right now. We've got Northrop Grumman Cygnus, and we have SpaceX right now. One of them can land, and one of them can't. You know, we catch theirs on fire before it re-enters and burns up in the atmosphere. But when we have Dream Chaser into the field next year, now we'll have two vehicles that will be able to bring home cargo. And, you know, a lot of cargo is fragile. So a lot of things that we do scientifically on space station, the sample would be destroyed by the impact of landing in the ocean. It's just too high of a G, and it usually breaks the sample. So when we get back to the days of the shuttle where we're able to do a landing, a soft landing, we will be able to return different types of science home that we're not able to do today.
And we're seeing lots of other space transportation systems that are unmanned. So Space Forge, Space Rider, Hudson Space Systems, Varda. So you're seeing lots of models with this. And I would just say, and then I think we'll have another question here. I did an analysis for Dunkin' Donuts. And when you put 3 Dunkin' Donuts right adjacent to each other, the business improves for all 3 businesses. It's counterintuitive, but it is true. So I think the pie gets bigger as we have more options. On that note, because I love Dunkin' Donuts. All right.
Thank you all so much. My name is Anna Volker, and I have a question for the panel on behalf of SciAccess, which is a nonprofit I run. So right now we're doing a project called Mission Astro Access that's really focused on testing tools and technologies in microgravity on a series of zero-G parabolic flights. And the purpose of that is to pioneer technologies that can make this future generation of space stations more accessible. And as a next step, what we'd really love to do are connecting our disabled research teams with every company involved in building this new generation of architecture in order to make that accessible from the start, instead of trying to retrofit those space stations for disabled astronauts 10 years down the line. And so I'm curious to know if your companies have started to tackle this issue in any way, and if they'd be open to the idea of working together to build those infrastructures in more accessible ways from the start. Thank you.
Well, yeah, sure. I'll try to answer that. Yeah. So, I mean, to answer your first question, I think when you look at crew members, you have to look at all scenarios. Especially in space, there is no one to treat you. So it's not a question of necessarily ease of use, but it's a question of what happens if there's an accident and we have to stabilize a patient. So you have to look at all those cases. In terms of providing the connections and networking to actually start developing mission profiles or payloads. I mean, there are organizations like KSC, which work with the ISS, although I believe it's a new name, or is KSC the current name? ISS National Lab. Thank you for correcting me. So there are those agencies which control that. But in terms of if you're trying to get maybe market research of what are some capabilities that are going to be coming up in the future, yeah, I would say that there are people that you can talk to.
Well, and you're right about that because, things are designed the way they're designed. I always wanted to be an astronaut, but then I got to be 6'11", and if you want to see something funny, sit me in one of the capsules. I've sat in most of them, and I have a picture of me sitting in most of them, and every one of them, could be a cartoon in some feature. Things aren't designed for everybody, and, it is something we must consider, in the future as to how would you accommodate differing size and different types of people.
All right, I'm noticing we have 4 minutes left, so let's do rapid fire questions and rapid fire answers.
Hi.
Oh.
I just have a quick question about accessibility for K-12 students, because some of you have talked about that they don't have to have the technical background or they don't have to go to college. So where do you see the K-12 pipeline fitting into your industry?
Higher Orbits has been doing really well with that. So there's, Higher Orbits has been packaging and having high school students and lots of experiments. I think Blue Origin has provided, $1 million to do that. Blue Origin has their own competitions for high school students. I think there's more and more, and with more access, I think this will be, that's one of the sectors is education and STEM that I think I would see these service providers.
Well, that's a really good example is technicians. So we've actually used that before, where we'll do everything from stockroom to, the basic technician tasks that they can be trained for. We've used high school students, graduating seniors in particular, to give them experience kind of on the internship type level. So we have done that in the past. Not every job does require to have a college degree. And we do a lot of self-training, particularly for our electrical technicians and self-certification. So there's no reason why, a young, fresh out of high school can't come and work in the aerospace field.
All right, thank you for that question. I saw other hands right here.
As a congressional staffer, I have to work with my colleagues on the Hill to sell this stuff. If you had 30 seconds to ask, what is your ask, and why should a congressperson support that?
Such a good question. So, did everyone in the room hear that question? That was such a good question. And why don't you just introduce yourself and who your congressman is?
My name's Marcy Callan. I'm Congressman Connor Lamb's district director. The congressman sits on the Science, Space, and Technology Committee. So it is my job to work with my colleagues on the Hill and him to relay some of this information. So I'm wondering, if you had 30 seconds in an elevator with Congressman Lamb, what would your ask be, and why should he support it?
I think my 30-second answer, and I'm gonna really try to stay the 30 seconds here. One, this type of technology seeds the market, and when I mean seeds the market starts growing on itself. So it's an investment that returns dollars. So it's tax dollars that are actually turned into valuable investments. And number two, it also ensures the United States security in space. So as we develop our technologies and we become stronger, then the whole country as a whole will also be stronger.
Well, I think it goes.
You said you were a staffer.
Yeah.
I would say pilot funding to identify the very impactful science technologies to develop that pipeline and translate that and de-risk for implementation partners, streamline that to space.
I think it's the benefits to Earth that you got to consider as well. Everything from medical to We did an experiment with Procter and Gamble where you would think that, Tide laundry detergent is an important thing, but it is. It's, something that's used all around the world. And, they were able to save lots and lots of money because they were able to extend the shelf life based on what they learned in space, on the space station. So I think it's a lot about return on investment and the technologies that are on Earth that don't have to be the phone in your pocket. It also includes laundry detergent and other things.
If I may, one of the panelists earlier was talking about the importance of stories. Using a concrete example like Tide is a great way to get your message across, because that takes all of the high-level stuff you've been talking about and brings it right down to what people have in their basement. That's good.
Thank you.
All right, we are out of time, but Ken and Ken?
They had great answers.
They had great answers.
Ken Savin was right. He said, I should not ask any questions, to just open it up to you guys. You had the best questions. I should have just put duct tape on my mouth from the beginning. Honestly, do you have a 2-second answer? Are you good?
No, in all honesty, regulatory policies that free up the commercial sector to operate in space, seeding the demand side of the equation for high-tech startups and people who want to go do this stuff in space, and fundamental research and discovery, because that's the mulch that's going to cure cancer and leukemia and so many other things. Another great example, macromolecular crystallization studies contributed to the discovery of Keytruda, which has been a huge improvement in treating cancer patients from Merck.
Not much to add. I think the fact that we want to maintain our leadership in technology, these are the types of things you do to do that. It's inspirational, gets the next generation to the K through 12, gets people thinking about it. It's a way to keep our people trained, and it also makes everyday life better through things that, again, are seemingly mundane in our lives, but there's a lot of technology and effort behind that, and things like this lead us down those paths.
Good. Well, join me in thanking this amazing panel for a great conversation. Thank you for your questions.